Hello, here we are again for our, I believe is the 11th episode of coding an Elm clone, Tetris clone in Elm. Not there yet, but yeah, so last week we left off by being, or enabling full lines to be cleared eventually. And I actually realized only after recording that that's really the thing that makes the Tetris playable, so that was a big step. But to make it fully playable, we also need to be able to detect when the game is over. So that's something that I want to look into today, and maybe also start a little counter about how many lines we've cleared. So without further ado, let's get straight to it. Okay. Editor is still open here. Let's close all this just to see git status. Everything is where we left it up last week, so that's great. Cool. Got the right mouse here. Open up the Vim again. So yes, the way I want to algorithmically approach this is, I guess, to be like, when we spawn a new piece and we are not able to drop it onto the current board, then we basically can conclude that the board is full, or just thinking about it. Yeah, that's probably like, I was considering like, can we generate a function that just calculates if the board is full, but the board does not to be full, like it's really only that the position where we want to drop this new piece has to be full. So I think we like just using this existing function that we already wrote is probably the easiest, laziest, simplest way to go about it. So yeah, let's do that. So where do we generate these new stones? So and we use the random generator to use this. So we went over this pattern where we have to issue this command that gets executed when the outside world has generated a random number. And when we receive this command with the generated random number, that's when we generate this new piece. And I think that's also the best position where we, instead of setting the current piece to this new random piece, we actually determine if the game is over or not. So let's jump to the update function where we actually, or let's see, what did we call the message? New current piece. That's here. So if we search for that, then we should find, here's our update function. That's when we spawn a new piece. So I would say we either rename, or maybe we just replace this function with a new one. So how do we call this one? Maybe test if game over. And we take a model and receive a model. Or no, wait, maybe we call it game over or new piece. Cool. And instead of calling, or maybe we just make this complete first, call model equals, and then we just replace this call with game over or new piece. We still need the piece index, and the old model. Jump down to our implementation here and just drop that in. Piece index. That's probably an int if I remember correctly. Let's see if that compiles. Compiling without errors. That's great. So now we can add some logic here without polluting our update function. Like the update function is a super central place in each Elm application, and it grows linearly with the number of different events that we are tracking. So to keep that short, we want to put in as little logic into that as possible. So I would say if, then we probably want to say can drop something somewhere, then we spawn the new piece, else game over. That's obviously pseudocode, so now we have to fill in the gaps. And yeah, let's see. Spawn new piece. Spawn new piece. What does it do? New piece. Maybe actually. I mean, spawn new piece is also not super complicated, so that's cool. Like the thing now I'm contemplating is to call can drop. We need a current piece and a board, and then we get a boolean. So now if we want to access the new piece that we use in spawn piece, then we have to either pass it down or create it another time. So I'm not sure if I like that, but I think I will just grab some stuff from down here and then we can consolidate it afterwards. So now we have the new piece. We say it can drop new piece, oops, on model.board. Then we do this, and otherwise I don't know. Otherwise, like for now, we just clear the board, maybe to just have a visual indication on the board itself. So let's say model board equals make empty board with where does the E come from? With board height. Let's close this window. How does make empty board get called? With board height, or we can just steal the whole expression. Boom. Throw this away, close our expression here. Okay, so does this compile? No, pdef. Where does pdef come from? Okay, so we have to steal this expression as well. Okay, that compiles. So let's see how this works. Trying to make the quickest game here for it to end. Boom. Okay, I think that was one early. But it's good enough for now. Like, I think we can tweak the exact expressions a bit later. Like this test. I'm not even sure if the new pieces spawn in the right position. That looks good. Okay, anyway. The main thing I wanted to go at tonight was anyway, how do we model the the code around detecting, or not detection, but the representation of the state when the game is over, because that's, I think, something that is like where Elm has a pretty direct approach to, but it's kind of not in the mindset if you come from an imperative programming language. So maybe we work out some. No, I think I just go right at where I think I was going, and the main idea is like I want to represent this somewhat clear in our model state. So this, we have the state here, so we could, like, one idea that you could come up with is to have is over boolean here, for example. So that's something that I think comes very naturally if you think in terms of JavaScript or whatnot. But the thing that is more logically consistent is to really, because the state is mutually exclusive. Like a running game is mutually exclusive from the game over state. Like we will not flip-flop back from a game over state, so it's a really clear distinctions, and I think it makes sense to also express this in our code, and that's where we can use the power of the algebraic data types again. So the way I want to go about it tonight is I'm going to introduce dedicated variants for our model type. So let's call this one running game. And this is something that's also, I saw a lot of nice tweets about Elm this week again, where people say like, okay, if I would do this in JavaScript, that's like you have to plan out this change, and I would be freaked out about all the members, like the properties that change and all the if statements that I have to worry about. But in Elm I have zero concerns. I just make the change and then I follow the instructions by the compiler basically. So the other state, the other variant, is the game over state. So let's fix the indentation here a bit, just to give the formatter enough to work with. Why is it unhappy? Because it's not an alias in that case anymore. So now our model can be in two mutually exclusive states. Either we have a running game or the game is over. And now we can follow you. We probably got a good chunk of, why is it not scrolling here? Yeah, we got a few places to address. So I could either like just work my way through those, or like follow my gut, like where I want to start. I have a pretty clear idea where things are probably ambiguous now. And I think the first thing I want to address is the update function. So let's go there, update, boom. And because this allows me also to show one pattern that I saw the first time in the Elm SPA app, like this demo app from Richard Feldman that he created to showcase how a real application, complete application with Elm could look like. And the thing here is that we see these functions, all like the drop current piece, the move piece, they take the whole model, and obviously these functions will now trip because model can be more on what they've been working with or something different, a different variant. So the easy trick to get out of this without having to handle the different variants of the model in each of those functions is to deconstruct it right away here in the update function. And the other thing that is addressing is also that all these functions here, the gravity tick, the key down, the new current piece, these functions all make no sense in the context of the game over state. So we don't want to handle any of those cases explicitly. So we will combine this, in this case statement, we will combine the model and the message to a tuple, and then we can pattern match on this specifically. So now we can say The message is still what's in the front here, but in this tuple, the second element of this tuple will be the model. So now we can say running game, and we say game. Let's call it game details. And we will do this for the rest of the branches of the case statement as well. So here we go. Running game, game details. Here as well. Game details. And the no op, like we can basically replace this with the underscore, which means now this case is, in this case statement, any of these branches that are not matching, or any of these expressions that don't match any of the three branches that we have explicitly pattern matched here, will false through and just do nothing. And like this will definitely fix our update function, but it also adds some loophole to regressions into our update function, because like in the early episodes I bragged about how Elm allows us to check our case statements for completeness or exhaustiveness. So now, of course, if we have a fall through case that just matches any of the unmatched cases, we do lose this feature that the compiler will hint to us or point us to missing update branches. But if you followed so much along with me, and you've written your one or two Elm applications, then you like. In the case where you introduce a new message, you don't need the compiler anymore to help you. Like, it's still helpful in a lot of other cases. So whenever you make this, you introduce this pattern where you, or this pattern match to any of your case statements with the fall through, then you should be aware that you're trading off this advantage that the compiler will give you a hint when you add a new variant to the pattern that's matched here. You lose this hint from the compiler that you have to add another branch here. So so much for that. Let's save this. Is still not enough, or maybe yeah, we'll just pass on the game details here, because that's the thing that is missing as well, because these now match again the same shape that our model had before. So that should really fix our update function. Mod, I don't know why I wrote mod here. It should be a model, of course. Cool, and now I will just clear the screen and save again, so that I get a complete picture in this shell of. That's all the things that the compiler is currently complaining about. So I would estimate that's a good 10 things that are wrong. So let's see what it's complaining about. The second argument of is not there, because we did fix how we call this. That's one of the places where we replaced model with the game details. So but the signature of this function, game over or new piece, just says explicitly that it wants to have a model. So that's not correct anymore. And to be able to fix those signatures, I will actually introduce a type alias. Whoops, game details. And we'll just copy this over here and say running game has one parameter game details. That will not fix it. For first I made I forgot an equal sign here. Oh, not there. There. And now we still have to go back to this definition of game or new piece and replace the model parameter with a game details parameter. So where was I before? Not there. I'm just going to search for this. Here we go. So now this is not model, this is game details. And also And now this is a bit tedious exercise, but it's like we could leave the local identifier for this of the parameter name for the actual parameter at model and it will still work, but it's of course also a bit confusing. So maybe actually instead of how do we go about this? Because like I'm just wondering what we're accessing. I think I'm just going to replace a model with game details here. So change to game details. Next one, next one, next one. Okay, and then like this is a pattern that we'll have to basically go through the whole program for. Be a bit more explicit here. Yeah, game details. And also, like also when we create this, because like, okay, let's take one step. What do we call this? We call this in our update function. So if we receive the new current piece, then we want to create this new model state. So this function still has to return a value of type model if we want to be able to return it from our update function. So let's see, and I deliberately did not update the return type here. So this is still a model. But now we have to see in these two cases where we return actually expressions from our function or calculate the expression that our function represents, we have to make up our mind. Like if we want to continue to, well, actually it's one case gets really simple now. Here we can now finally write game over. So that's great. But here actually we have to decide if we want to return like ultimately we have to return something like this, running game. And I think that's actually the solution that I want to go with, because that makes the signature of the of our spawn piece function nice symmetrical again. So we have game details to game details. So let's stick with that. Does this still make sense? Now we want to rename here our model, our local parameter name, actual parameter name again to game details. This is used here. And then now let's just save and ask the compiler where we should look next. 288. Move piece. From model to model again doesn't make sense because model can now be also a game over or whatnot. So we will just replace this with game details. Same here. And rename our local parameter name to game details. I could probably make this smarter with search and replace, but I also want to use the opportunity to go over the actual functions affected by this and to make clear that why this makes sense for this particular function. Cool. Line 390. Drop current piece does also not make sense on the whole model. It's something that we want to operate for game details. But now we see like, okay, this returns this tuple of model and command message, which is exactly what our update function wants to return. So here probably makes sense to continue to return that. I mean, it's something that I might want to revisit as well. But let's stick for this to make as few changes as possible to get it compiling again at least. So yes, we want to replace this. And now, whoops. Let's just go back here. That's one of the return values for our function. That just springs to my eye because I see this command none here in the tuple. So I know already I have to prefix this to with running game to make it a legit model value. Okay, let's jump to the next one. Same here. This has to be a running game, and this will operate on game details. Same here, game details, running game. And then this function is done. Let's see what comes up next. Line 500. Yeah, and this is an interesting one because now we basically, this board view expects a board and a current piece. So the good news is, like, we already have a function that's a bit more independent from the whole model. Well, not truly, but at least it's what it consumes. Yeah, the function itself is independent of the model, so that's good. What's not so good is that where we call it, whoops, where it just was, like here we're still accessing directly the model, and the model does not have a direct board field anymore because now it has these two variants, especially in the game over. There's just currently no. So maybe we can use a case statement here again, where we just pattern match, where we say, like, if it's game over, then we just render a text. Like, let's be really minimal. Game over. And if we have, what was the other one? Running game. And we can, again, like, deconstruct here directly to make it a bit more concise into current board and current piece. Then we continue to render what we had before, and now we can just remove the model axis here. So let's save this. Whoops. And next one to address is in line 199. That also makes sense. Our init function, we initialize directly now with a running game. Boom, line 231. Move piece. What does move piece want? Move piece takes game details and returns game details. So the other option is to just make these game details into a proper model by just prefixing it with a running game. And we're compiling again. Woohoo! Let's see. How fast I can end this game. Maybe I should increase the speed with which the tiles are dropping to make these tests a bit faster. Boom! Game over. Success. So that's great. Now this is a bit abrupt, I would say. So maybe we want to still display the last state of the board when it was finished. So, and now it becomes straightforward because now we truly. How do we do this? Well, okay, maybe it's like there's still several options. Like, what the straightforwardness is about it is now I know exactly where to go to add this information. I can just add it here, actually. Like, maybe let's be really straightforward, and I'm just going to add this board information to my game over state. So now what will happen? We will be told again where we have to touch. So 499, and here we have a board now. What else? In 262. Okay, so this is like, and again, I just love how the compiler, if my data structure are logically well formed, it's like the compiler knows where I have to put the logic, and all the logic is in place here. So that's great. Like this is where we basically create the game over state when we lose the game. So here I can now just grab the board from the game details and add it to our game over state. Boom, on there. what else? It's compiling. So I'm pretty sure like it still will just work exactly like it worked before, but we are not doing something with the new board information we have added to the game over state yet. So let's do that right away to see what to do with that. So what we can basically do is we can just, I mean, this is bad. Like this is also the layout. Maybe we are just like, we just ignored all this, my boilerplate that I always have on top here to have it running in my pre-roll before I start streaming. So let's create a little wrapper function for this that we call layout, and it takes content, and we grab the layout here, boom, and we just, what do we do? Yeah, let's put the content here. So now we just call layout, pipe in this board view. So does it still compile like this? Make sure our refactoring works. Yeah, cool. So now we are going to drop this over here, and now we are just going to put something, generate something on the fly here, new div, and on top of this div, no, actually, yeah, let's put the text at the top here, put in that as well, closing bracket. Does it compile? Wonderful. It does not compile because we don't have a current piece. Current piece can be nothing, so I will just put in nothing here. Now it's compiling again. Actually, let's speed this thing up. Where are our subscriptions? Subscriptions. So let's say every 100 milliseconds. That should speed things up a bit. Boom, yes. And ding, 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 game over. So, I mean, obviously there's some UI work to be done, but like at least I cannot move any things, and that's good. But and actually that reminded me of something. We also can now be a bit more defensive about the events, because we are still firing these events, like our key down event and our gravity tick. All those things are still fired. We are just not handling them currently in our update function. So we can be a bit more precise here and say, like, if our model is game over, then we don't want to listen to anything. And otherwise, what was it called? Running game. We don't care about the actual game state or the game details. Let's be precise here. Game over does need a first argument that we don't care about. Great. So everything will still work. There will be no direct user impact by this that we can see changing from what I did. But the good thing now is that we don't have our wheels spinning in a, so to speak, figuratively speaking, in a game over state. So in this, what, like in JavaScript terms, what that means is once our program loop in the runtime engine of Elm detects that we're in the game over state, like it will unregister the event listeners to those events like this, our timeout and our key down handler. Cool. So that feels really good. I don't know. Maybe maybe I spent 3 minutes on CSS to make this a bit more satisfying. The game over display. Where was the game over? Here. Let's put this in a div that we can position. Whoops. I guess this is class. Let's call it game over. Does it still compile? No, it doesn't know class. I would assume class is actually a function that's exported from the HTML attributes packet. Is this correct? Yeah, it looks good. We can just briefly look it up as well to confirm. Elm HTML attributes. Boom. Let's search for it here. Class. Often used with CSS to style elements with common properties. Yeah, that's a very nice description what CSS classes are for. Cool. So that means our game over container has now a CSS class of game over. And where is this situated on our board here? I don't know. Yeah, let's style it on the fly in the here. So let's bring this to the side. Inspect this container. So it sits over our SVG. That's great. Let's say position absolute. Absolute, is this correct? We now see already it overlaps a bit the game. Let's say color red and top 100 pixels. Left 20 pics. That's great. Now let's say CSS drop shadow generator. Boom. Yes, agree. Color, let's make it white. Oh, that actually should be probably the last one, but that looks good already. I just want to make it white. Grab this expression here and throw this in here. Wow, that looks damn ugly. Okay, maybe I'll just make this white for now. That's a good start. So let's see. I think I have an assets directory with some CSS here. Drop this one in, and what was the CSS class? Was game over. Boom, game over, curly brackets. Save this sucker, reload. Quickly wreck the game. Boom, some very cheap styling right there. So that's great. Yeah, that's all I wanted to achieve tonight. I think next week something I definitely want to look is to create a score. We still have the task of like animating the vanishing of the lines, maybe a bit nicer. So stay tuned for this next week. Thanks for staying with me today again, and see you next time. Bye bye.